In today's video, I will solve a problem based on slope deflection method. So here the question number 1 is analyze the beam by using slope deflection method. So here this is the beam where both sides are fixed, and here one roller support is present, and here one load is acting, point load is acting, that is 30 kilonewton, and from this point is A, this point is B, and this point is C, and from A to B one UDL is acting over this span of 10 kilonewton, and the length from A to B is 5 meter, and from B to this point is 1 meter, and from this span to this is 2 meter. So here the total length from B to C is 3 meter. Okay, so this is the beam, and we have to analyze this beam by using slope deflection method. Okay, now as I already mentioned in my previous video, the steps of the slope deflection method, so we'll follow the steps here in this problem. So the first step is find FEM. And what was FEM here? FEM is the fixed end moment. Okay, so first step is to find the FEM. So now for FEM moment, fixed end moment for AB and is equal to, so now from A to B, from A this to this, A and B is UDL, okay, of 10 kilonewton, and the span is 5. And I have already mentioned in my previous video that in the fixed end moment we have to consider that all the points are, we have to assume all the points as a fixed. Okay, so here now from A to B, what is that? We have a formula. See, this one also I have already mentioned. The maximum bending moment will be like this, and here this is the maximum bending moment diagram, and here at the top for the UDL is WL square by 8, and for this type of span to find the MABF is equal to, the formula will be minus WL square upon 12. Oh, I'll write down here only. Okay, minus WL square by 12. Now here A to B, minus W is what? 10 into L is 5. This is 5, right? So square upon 12. So we'll get the value around minus 20.833 kilonewton meter. Now we have to find for MBAF is equal to, it will be positive WL square by 12. So the value will be 10 into 5 square upon 12 is equal to 20.833 kilonewton meter. Okay, so now this is the span for A to B. Now we have to find for B to C, and we have to consider both the points are fixed. So here now one point load is acting here, 1 meter and 2 meter, and the whole length is here what was the 30 kilonewton. So in this case the fixed end moment from B to C, that will be MBC, fixed end moment from B to C for a unequal, and this load is acting at a distance of 1 meter from B. Okay, so this is not equally distributed, right? So now for this condition, what will be the formula for MBC will be minus WAB square upon L square. Then the value will be minus W is 30 into this distance from B to this point will assume at A, small a, and from here to here will assume as B. Okay, so now what is the distance? A is 1 into B is 2 square divided by L. L is the total length, that is 3 square. Then we'll get the value around minus 13.33 kilonewton meter. Now we have to find for CB. Now for fixed end moment for CB is equal to, it will be positive WA square B upon L square. Now what is W here? 30 into A is 1 square into 2 divided by L square is 3 square. Then we'll get the value around 6.667 kilonewton meter. So now we have a value for MCB is itna, for MAB fixed end moment for this one is this, and for BC is this, and for CB is this. Okay, and for BA is this one. So now the second step number 2 is to apply slope deflection method. I'll write in short, slope deflection method for each span. Okay, so first we'll find for span AB. Okay, so now we know the formula, that is MAB is equal to fixed end moment around AB plus 2EI by L bracket 2 plus B plus 3 delta by 2. Okay, sorry, this one is not plus, this one is minus. So this is the formula, and we have to find for each span. And okay, we'll write the formula for BC also. Okay, so this is the formula we have to assume when we considered from we have to use this formula while calculating moment from left to right. Okay, left to right. And if we consider the moment from right to left, then we have to use this formula, that is M, this one will be BA now. So MBA fixed end moment plus 2EI by L upon 2 theta B plus theta A plus minus 3 delta by 2. And this formula will consider when we'll calculate for MBA, that is for right to left. Okay, so these are the two formula which we have to calculate for each span. Now we are considering for span AB. So again I have to draw the diagram. The diagram was like this. Here A, B and C. Here UDL was acting here, point load of 30 kilonewton, and here 10 kilonewton of 5 span 1 and 2. So this was it. So now we have to calculate for this span. A to B. Now we have a value for MAB is equal to, we have a value for this one we have already calculated, that is MAB. MAB is 20.833. So minus 20.833 plus, now with this value is 2EI. We'll keep it like this only because this value is not given in the question, so we'll keep like this only. And L, for this span L is 5. Now 2, see 2 theta A. So here for theta A, always remember that at the fixed end theta value will always be 0, and this thing I have already mentioned in my previous videos also, so you can go and check it out there. So the value for theta A will be 0, so it will be 0 plus, here it's a roller support, right? Some value will be there, so we'll keep it theta B, minus, here in the question there is no deflection mentioned, so delta value also will take it as 0, so it will be 0, so it will be minus 20.833 plus 2EI theta B by 5. Okay, so let's consider it as equation 1 for MAB. Okay, now we have to calculate for MB, this one. Okay, so now for MB A is equal to, now MBA, we have already got the value for MBA, right? 20.833 positive. So 20.833 plus, what was the formula here, plus 2EI by L. L is 5, L will be 5 bracket theta B, some value will be there, theta B plus theta A is 0 minus 0, so the equation will be 20.833 plus 2 to the 4 by 5 EI theta B. Okay, so let's consider this as equation 2 MBA. So now again, see here we have to apply the SDM for each span. So for span AB we have already got 2 equation. Now we have to solve for the span BC. Okay, so now for span BC we have to write the formula again. For MBC is equal to MBC fixed end moment about B to C plus 2EI by L. So it's BC, then 2 theta B plus theta C minus 3 delta by L. The equation will be like this for B to C span. So now we have already the value for fixed end moment for BC. For BC, this is the value. Okay, so minus 13.33 minus 13.33 minus 13.33 plus 2EI by L. L distance was 3, right? This 3. Now for BC, C is fixed, so C will be 0 and B value will, something will be there. Okay, so we'll keep it like this, the B plus C will be 0 minus 0, so the equation will be 13.33 plus 2 by 3, 2 to the 4, so it will be 4 by 3 EI the B. So moment about B to C, let it be equation 3. Okay, now BC for moment about C to B. The equation will be CB, fixed end moment, plus 2EI by L. So 2 theta C plus theta B minus 3 delta by L. Okay, so now we have a value for this. We have already solved here. That is, for CB is 6.667. 6.667 plus 2EI by L is 3. So here this theta C point is fixed, so it will be 0 plus theta B, something will be there, minus theta is 0. Okay, so now the equations becomes 6.667 plus 2 by 3 EI theta B, M moment about C to B. Let it be equation 4. Now we have 4 equations, right? So the third step is to apply condition of equilibrium. So we know the condition, that is MBA plus MBC is equal to 0. So here MBA, we have an equation, right, for MBA. What was the MBA? This one, no? This is the equation number 2. So MBA 20.833. Okay, so we have to write here the equation, that is 20.833 plus 4 by 5 EI theta B. This is the equation for MBA plus. The second, we have to write the equation for MBC. MBC is this one. MBC. MBC is this one, right? So we have to write here plus minus 13.33 plus 4 by 3 EI theta B is equal to 0. Now we have to solve. After solving, we will get the value of EI theta B is equal to minus 3.51. Done. So now we have a value for EI theta B, that is minus 3.51. So in the step 4, what we have to do, put EI theta B is equal to minus 3.51 in all the 4 equations. Okay, so now we have equation 1. See, we have equation 1, 2, 3 and 4, right? So we have to put this value in all the 4 equations. So now MAB is equal to minus 20.833 plus 2 by 3. So the value of EI is minus 3.51. So after solving, we'll get the value around minus 22.23 kilonewton meter. Okay, so now for moment about B to A will be, the equation was 20.833 plus 4 by 5. Then we have to put the value here, 31. Then we'll get the value around 18.022 kilonewton meter. And now again we have to find for BC and MCB. So I'll directly write the answer. So the answer will be around minus 18.01 kilonewton meter, and for CB is 4.32 kilonewton meter. Okay, now the 5th step is to find the support reaction by separating each span. Okay, so the 5th step, I'll write find support reaction by separating each span. Now this is our fifth step. So here we have to separate each span. See, in the question it was like this, right? From A to B, it's a roller, so it's a A point and B point, and again this one we have to separate. B point is a roller and this is fixed C. So by separating we have to find the reactions. Reaction means vertical reaction, RA, RB, and for this span also RB and RC. Okay, so we have to find those values here. Now see, here from A to B, UDL load was acting and it was around 10 kilonewton and the span was 5, and here 1 point load is acting, that is 30, and from B to this point is 1 meter, and from this point to C is 2 meter. Here it was 5 meter. So now see, we have the moment also with us, right? This is the moment for MAB, A to B. So from this A to B, the moment, see, the moment is minus 22.23. Minus means ki it's always anti-clockwise. So here one anti-clockwise moment is acting and the value for anti-clockwise is 22.23. 22.23. Done. Now again for BA, for B to A is positive 18.022. 18 positive means it's a clockwise direction. Okay, here the moment is acting in a clockwise direction, that is 18.022. Likewise for this span also we have to see, for this span the value is minus 18.01, so it's a anti-clockwise 8.01, and for this is positive 4.32, so it will be clockwise 4.32, right? So we have a value, we have all the values with us. So now we have to find the support reactions. Now see, we first we'll solve for this span. Okay, this span. So now now see, we'll consider moment about A is equal to 0. So now first what we'll do, see, this is anti-clockwise, right? So the value will be minus 22.23, right? Anti-clockwise we'll consider as negative and clockwise we'll consider as positive. So here this is a anti-clockwise, so minus 22.23 plus this load is acting, downwards, right? Downwards, so we'll consider it as positive. Okay, so plus 10, UDL means we have to take the distance also, right? Into 5 into we have to convert this load to a point load. So to convert it in a point load we have to take half of it. Okay, half of the distance, so half of the distance will be 5/2. Then plus this moment is positive, right? So it will be plus here, plus 18.022. Now this force is acting upwards, so we have to consider it as minus RB into moment about A. So we have to take this distance, how much distance it will cover to reach this point is 5 into 5 is equal to 0. So from here, see, we can get the value for RB. So here RB is equal to 24.15 kilonewton. Now we have a value for RB here. Now we have to find for the RA. So RA is summation of all the vertical forces is equal to 0. See, for this kind of problem we have already solved in our strength of material for finding the shear force and bending moment diagram, right? So see, summation of all the forces, vertical forces, is equal to 0. That will be RA plus RB is equal to, here, all the upward forces, sum of all the upward forces plus is equal to sum of all the downward forces, right? So here upward forces are RA and RB, sum of RA and RB, and the downward force will be 10 into 5, right? So now RA, we don't know the value for RA, but we have a value for RB, right? This is 24.15 is equal to 10 into 5 is 50. So from here we'll get the value for RA, that is RA is 25.85 kilo Newton. Now we have a value for RA and RB. So here RA is 20, sorry, here RA value is 25.85, right? 25.85 kilonewton, and RB is equal to 24.15 kilonewton. Now we have to solve for this one. Okay, so we'll solve here. Now same way we have to solve summation of all the moment about B is equal to 0. So here this force is anti-clockwise, so it will be minus 18.01 plus 30 into distance covered up to here is 1, so it will be plus 30 into 1 minus RC, this value RC into 3, right? RC into 3 plus this moment is clockwise, so positive 4.32 is equal to 0. So from here, from this equation, we will get the value for RC is equal to 5.43 kilonewton. Okay, now again we have to find the value for RB and RC for this span. So now summation of all the vertical forces is equal to 0. That will be RB plus RC is equal to 30, right? 30. So now RB plus, we have a value for RC here, 5.43 is equal to 30. So from here we will get the value for RB, that is 24.57 kilonewton. Now here also we'll have the value for RC, that is 5.43, and for the RB is 24.57 kilonewton. Now the next step is step number 6 is to find the final support reaction. Okay, so here RA value, what was the RA value here in the step number 5 for this span? Sorry, wait, I'll draw the diagram again. This one was like this, A, and this point was roller. What was that? It was a roller, yes. It was like this, and roller support was here, and here UDL acting A, B and C, and here one point load of 30, UDL of 10, span of 5, span of 3, 1 and 2 meter, right? So this was the here. So here the RA value, we have to find the final support reaction. RA value is equal to, what was this? RA is 25.85 kilo Newton, and RB value is RB here. We have a value RB value around 24.15 plus one more RB value is there, right? 24.57. So we'll get the value around 48.72, right? 48.72 kilo Newton, and RC value is equal to this one, 5.43 kilo Newton. So these are our final support reaction values done, and the last step is to draw the shear force diagram and bending moment diagram, right? So now we'll draw shear force SFD and BMD. Okay, so here I'll draw the beam again, 30, 10, A, B and C. Now we'll draw the bending moment first here, B. So see, for the bending moment diagram for the UDL, obviously the bending moment diagram will look like this. It will be a parabolic, right? And the maximum bending moment will be WL square by 8. Then we have to, after putting the value, we'll get the value around 31.25. and for a point load here, so the bending moment diagram will be like this for this span, and the maximum bending moment for this particular point will be WAB by L. So after putting all the values here, we'll get the values around 20 kilonewton meter. This is the bending moment diagram. But here we have to draw another diagram that is called as net bending moment diagram. Okay, so how to draw the net bending moment diagram? I'll draw here. Okay, so for determining the net bending moment diagram, we have to remember this concept. Okay, this one is A, B, right? Again we have to draw B to C. We have to separate this span. Okay, and always remember, for the first span the upper will always be minus, plus, here minus, plus. This is the sign convention of net bending moment diagram. Net bending moment diagram, and down will be positive, negative, positive and negative. Okay, so we have to follow this to draw the net bending moment diagram. So now we'll draw. Okay, so this is our span, whole span, right? A, B and C. Now for A bending moment diagram, we have already got our values here for MAB, MBC, these values, right? These values, we have this and this values, right? So we have to put, so first value was MAB. Okay, I'll write down here. So the first value is minus 22.23. so minus means it will go up around 22.23, and the second is MBA. MBA value is positive 18 point something, so positive is also up, so 18.022, it will also go up. And again the B point, MBC value is 18.011, so for BC it's negative, so it will again go up, so here 18.01, it will be somewhere here. And for BC to be MCB, the value is 4.32, right? So here the net bending moment diagram will be something like this. Okay, so now we have to draw this diagram here. So the net bending moment diagram will be something like like this. Here the value of 0.32, here somewhere B, here 18.022, 18.01, and here 22.23. so these are the net bending moment diagram. We have to set it this part. Okay, so these areas are known as net bending moment diagram. Now we have to draw the shear force diagram also, and to draw the shear force diagram is very easy. So now see, we have a value here. Again I'll draw this one. Okay, A, B and C, UDL and point load, right? 30, 10. So now we have all the values final, A, B and C, right? What was A? We have all the values here. See, these are the values RA, RB and RC, right? RA is 25 point, I'll write down here, 25.85, and RB is 48.75 and RC is 5.43. So now we have to draw the shear force diagram here. So here this 25.85 will take it as positive, so it will go up, right? 25.85. now 25.85, this UDL load is acting downwards, right? So it will be minus 10 into the span was 5, 10 into 5. So if we solve this one, we'll get the value around minus 24.15 minus. So the value will be somewhere minus means 24.15 here. So it's a UDL. So our bending shear force diagram will be like this for shear force diagram. Now again here again this force RB value is acting upwards. Again we have to take it as positive, that is 48.75. then after solving this, we'll get the value around positive 24.57. so 24.57, then it will again go up here 24.57. so now go up again. Here see, this force is acting downwards, then it will be minus 30. So the value will be around minus 5.43. so it's a point load, so it will be direct go down, and minus sign will be here around 5.43. so this is point A, this is point B, and this is point C. So this is the shear force diagram of the beam. So this was it. This was all about analyzing the beam by slope deflection method. So in the next video I'll be solving another problem. Thank you.